Good morning, everyone. We will get started here with the webinar on counters in just a couple of moments. All right, guys, we'll go ahead and get started on the webinar for this morning. Again, today we are going to be going over how to set up counters in the FC6A PLC. Again, here is the current webinar schedule. Of course, today we're doing counters. Tomorrow we will go over how to move data around the PLC. On Wednesday, we'll be covering some advanced math topics and the device data list within the PLC. Thursday, we'll start some HMI topics. Thursday, we'll do basically starting a project from ground up and doing some basic buttons, pilot lights, things like that. Next Monday, we'll continue along on that same trend, doing some basic objects in the HMIs. And then on Tuesday of next week, we will be doing some advanced configuration on HMIs. The link to the recorded webinars, and this webinar, just like all the other ones, is being recorded. You can see the link there to our YouTube channel where these are all going to be posted. And feel free to take a screenshot of that if you like. All of the webinar material that we post, for example, you'll get a PDF of the presentation, you'll get a copy of the program, whether it's the WinLadder program or the WindoI program, a consolidated question and answer document that we put together from questions of both sessions of a particular topic, and any other really supporting material that we feel like may be of help. I will post that as well. There's the link for that. And basically, once everything is ready to go, there will be a download link. Beside the name of the webinar, just click on the download button and you'll get a zip file of all the material. And just like always, to ask a question, just click on your question drop down, type it in, click send, and then at the end of the webinar, we will go over all the questions and hopefully be able to provide some answers. All right. All right. Oh, and just, I didn't introduce myself. My apologies. If you guys don't recognize the voice or if this is the first webinar you guys have been on, this is Britt Davis. I'm one of the automation managers for IDEC based out of Cincinnati, Ohio. All right. So let's take a look here at the different types of counters that we've got. And there's three different types. We're going to be doing an example of all three of these today. The first one is just a basic adding counter. It counts up. We also have a dual pulse reversible counter. What that is basically a counter that you'll have two inputs that can do counting. One will count up, one will count down. The third type is an up-down selection reversible counter. And in that one, you have just the one pulse bit, kind of like what we do for the adding counter. But you also have an input that will select if you're counting up or counting down. Okay? So those are the three types. The adding counter is a CNT. The dual pulse reversible is the CDP, and the up-down selection reversible is a CUD. Again, all the counters start with C. Now, you can have really a couple of different data types, if you will, for your counters. What we show there at the top, those are word-based or 16-bit counters. In other words, they will allow you to count positive whole numbers from 0 up to a maximum of 65,535. And if you use word counters, you can have up to 512 total counters in your program. You can see the device addresses there. They are all decimal based. So, like we talked about, the stuff that's all naturally a bit, like an input and output and internal relay, those were octal based. Counters are decimal based. So they can have, counter 9 or counter 18, for example. Again, those addresses go from C0 through C511. For the counter preset value, you can see you can do one of two things. You can hard code it or just type in a constant for the preset value. You can also use a data register to be able to adjust the value. And we'll go over this when we do some examples here in a little bit as well. The bottom counters there, those three that we show, again, those are adding dual pulse reversible and up-down selection reversible. Those are just double word or 32-bit counters. Okay, so in other words, those can count from a value of 0 up through 4.294 billion. Okay, so it uses 32 bits to hold the count value. This is what it is. You can have a total, if you use double word counters, you can have up to a total of 256 of those, basically half of the total number of word counters. Okay. If you use a mix and match of word-based counters and double word counters, then you just kind of have to figure out what your total maximum is. Again, for every double word counter, that uses 2, if you will, of the regular word counters. All right. So again, 3 different types of counters. The adding counter. Here's an example ladder diagram and a timing chart that kind of shows you what is going on. And again, if you consider the x-axis as your time axis, as you're moving along in time, you can see there we've got just the standard counter block. We've got a reset input there, which is the top input up here at the top, I0 in this example. And in this example, that reset input, what that does is it will reset the counter value to 0. You've got a pulse input here, input 1. That increments your counter value. So whenever we see I1 turn on, the counter will increment by 1. Again, the counter preset value can be a constant or a data register, either way. And the way the adding counter works is that whenever the count reaches the counter preset value, and in this example, it's showing a preset of 5 here. So whenever this count reaches 5, the output of the counter will turn on. And you can see down below there, we've got just a little bit of example logic, basically saying when input 2 is on and the counter has reached its preset value, the counter is true, it's on, that's that normally open contact of the counter here, then we're going to turn on output Q0. So if we look down below there in our timing chart, that top line is input 0, and again, that's our reset. You can see when that comes on and turns off. Again, we don't have any, that basically clears the count value. There's no value there. The counter is reset to 0. The line below that, you can see we're getting pulse inputs. Again, every time input 1 turns on, we increment the count by 1. Now, these counters basically have a one-shot or a single output built into them. In other words, we don't care how long input 1 is on. We're just looking for it to turn on in order to increment the count. It can turn on, stay on for 15 minutes. We're still going to only count by 1. All right, so again, as we get pulses there on input 1, we count from 1 to 2 to 3 to 4. Okay. Once we get to 4, you can see down below, if we go straight down this timing chart, you can see input 2 turned on there, and that's fine. That's just a normally open contact there in our logic. Once we get one more pulse input on input 1, the count increments to 5. Right below that, you can see the output of the counter now turns on. The counter is true. We've reached our preset value, so the count is on. The count is on. In our logic up here, we said when input 2 was on and the counter reached its preset value, we were going to turn on output Q0, which if you look in the timing diagram, you can see that happens. Input 2 is on. Once the counter reaches its preset value, it turns on. Output Q0 also turns on. Again, as we're going along the x-axis, you can see the next thing that happens up there is the very top line, input 0 turns on, which resets the counter. So at that point, our counter is no longer true, so that turns off. Our output also turns off at that same time. Okay. And then a little bit later, we turn off input 2. That's an adding counter. Again, you just got 2 inputs to the counter, a reset and a pulse. The next one is the dual pulse reversible. And you can see here, we've got 3 inputs now. Okay. This top input to the counter is a preset input. What that does is whenever this input turns on, the counter will, the current value of the counter will be set to its preset value. In this example, we've got a preset value of 500. So when input 0 turns on, the counter will have a value of 500. The next 2 are the up pulse, and in this example, it's looking at input 1, and the down pulse is looking at input 2. And again, whenever we get a pulse on input 1, the counter will increment by 1. Whenever we get a pulse on input 2, the counter will decrement by 1. And again, just like the adding counter, it doesn't matter how long the up pulse or the down pulse stays on for. We're just looking for the transition, just looking for them to turn on. Okay. And just like before, we've got just a little bit of logic down below. This is showing whenever input 3 turns on and counter 1 is true, then the output turns on. Okay. Now, the dual pulse reversible counter is a little different in that the counter turns on, or the counter is true, whenever the count reaches a value of 0. Okay. So let's take a look at this timing diagram. Our preset input, input 0, turns on. We have a value in our counter then of 500. If we get an up pulse, we have a counter value of 501. Another up pulse goes to 502. If we get a down pulse, that will decrement the counter, so that goes down to 501. Get another down pulse, it goes to 500. Another one, it goes to 499, and so on. If we get a whole bunch more down pulses, then we will get to 0. And again, once the counter reaches 0, you can see the counter output turns on here. Okay. When the counter is not 0, again, so if we get, once the counter is 0, we're moving along in time here on our x-axis, we get a pulse on input 1. The counter increments to 1. The counter is no longer true at that point. So again, this counter is on or true only when the counter value is 0. All right, let's take a look at the up-down selection reversible counter. On this one, just like the previous one, we have 3 inputs here to the counter. Again, the top input is a preset input. Again, that's going to set the value of the counter to its preset. And this example is also using a preset value of 500. The input below that is input 1, that's the pulse input. And the one below that, the third one, is the up-down selection. And in this example, we're using input 2. Whenever the up-down selection input here is off, you're going to be counting down. Whenever that input is on, you're going to be counting up. Okay? So in this example, we've only got 1 pulse input that we're looking at to either increment or decrement the count, and we're doing that based on this up-down selection input down below, input 2. Okay. All right, well, let's take a look here at our timing chart. Again, we've got input 0 turning on. That will move a value of 500 basically into the counter preset, or it resets it to that value, which we hard coded at 500. So input 0 turns on, the counter has a value of 500. If our up-down selection input I2 here turns on, now that means we're going to count up whenever we get pulses. So if input 2 is on and we get a pulse on I1, the count goes to 501. We get another pulse, it goes to 502. Now, if the up-down selection input turns off, that means whatever pulses we get now, we're going to count down. So once that input turns off and we get a pulse on input 1, we decrement the counter down to 501. We get another pulse down to 500, and so on. Once we get to 0, the counter will turn on or be true. Okay, so again, whenever the counter has a value of 0, the counter output will turn on. If our up-down selection input turns back on, so we're counting up and we get another pulse, we go from 0 to 1. When we get that pulse on input 1, our counter turns to a value of 1, which means the counter is no longer true. So our counter output turns off. And those are the 3 different kinds of counters. Again, I mentioned that you can have 2 different data types when you're doing the counters. You can use word counters or double word counters. And again, you can select that from the counter dialog box in the bottom left-hand corner. And we'll look at this when we get in the software in just a moment. Again, word counters are 16-bit, and those can have values from 0 through 65,535. Double word counters are 32 bits, and again, those can have values from 0 through 4.294 billion. Let's take a look too at the different device types that we work with when we work with counters. We have a C, which is just the counter itself. Counter C0, C15, C27, and so on. We have a device type of CP, which is the counter preset. Again, you can have CP0, CP1, CP30, what have you. CC device type is the current value of the counter. And if you're looking at C as a bit device, which we did in some of the preceding logic, that is basically just a bit of the counter. That's the counter contact. Whenever the counter is true or on, that bit will be on. Okay. So for our adding counter, again, the counter turns true. This bit would be on whenever the counter reaches its preset value. For the dual pulse and the up-down selection reversible, whenever the counter is 0, that bit would be on then. So those are just the different device types that we're working with whenever we do counters. Okay. Now, some comparison instructions. It can be useful to evaluate the current value of the counter just to be able to give the operator some feedback. You could be turning on either a light on the HMI, pilot light, a physical pilot light on your control panel. It could be a stack light, a buzzer, a horn that you're controlling, what have you. But you can use what's called the counter comparison instruction to either check to see if the current value of the counter is equal to a value or if it's greater than or equal to a value. And you can see there in the example that we're showing, that top example, we're checking to see is the current value of the counter 2, is it equal to 10? And if it is, we're turning on output Q0. The example below that, we're using a greater than or equal to comparison, and we're comparing the value of counter 3 and checking to see if it's greater than or equal to the value that's stored in data register D15. And if that condition is true, then we're turning on output Q1. So again, counter comparison just allows you to do control based on the current value of your counter. Some other comparison instructions that we've got, and we will take a look at some of these too when we do the examples in just a moment. You've also got data register comparisons, and those are similar to the counter comparisons in that you can do a comparison of data register if it's equal or greater than or equal. And again, you're just, instead of looking at the value of a counter, you're looking at the value of a data register. Those instructions are word data types. In other words, you can compare values from 0 through 65535. We've also got two other compare instructions. We've got our full-blown compare instruction, the CMP. That requires an input. You'll notice when we did the counter comparison as well as the data register comparison there, you don't have to have an input to control it. You can put it right up against the left power rail, and it will execute every scan. The compare, the CMP instruction, does have an input, so you can control when you're comparing and when you're not. The compare instruction also gives you an output within the instruction itself, and that can be an internal relay that turns on or a real-world physical output, the Q, that turns on. The compare instruction supports all the different data types. That's whether it's a word, an integer, a long, a double word, or a float. Okay, so you can use all 5 of those data types within a compare instruction. The load compare is also a full-blown compare instruction. In other words, just like the CMP instruction, you can compare if it's equal, greater than or equal, greater than, less than or equal, unequal. You've got all those different options. That one can also be put right up against the left power rail. You do not need an input. And it also supports all 5 data types, a word, an integer, a long, a double word, and a float. All right, let's open up Win Ladder and we will do some examples. All right, so I went ahead and put in some comments and created some custom monitor dialog boxes for us, just so I don't have to type all this in and waste your guys' time while you watch me type. So the first example we're going to do here is an adding counter. We're going to use 2 physical inputs on the PLC. We're going to use input 0 as the reset input. And again, when the reset input turns on, the counter value gets set back to 0. And we're going to use input I1 as the pulse input. And again, when input 1 turns on, that will increment the value of the counter by 1. Okay. Just some notes down there about adding counters. Again, the output of the counter will be on when the current value of the counter equals the preset. Okay. So again, if we do a counter that counts up to 5, whenever the current value of the counter equals 5, the counter will be on. Again, it doesn't matter how long the pulse input is on for. The counter is just looking for that transition for that input to turn on. Something to keep in mind, if your reset input is on, in other words, in this example, if I0 is on and I get pulses on I1, my pulse input, those pulses do not get counted. Okay. The reset input is kind of like the master. If it's on, it will force the value of the counter back to 0, no matter if we're getting pulses on the input or not. Okay. Adding counters will not count above their preset. So again, if I have a counter that counts with a preset value of 5, I can count up to 5. If I get more pulses on my input, it doesn't matter. It won't count higher than 5. And again, we can use either word counters that are 16 bits or double word counters that are 32 bits, just depending upon how high we need to count. All right, so let's do the example. Again, I'm going to use input 0 as the reset input. I'm going to grab a normally open contact, and I'll address this to input 0. Again, this is going to be my reset. My counters are here in my Home tab in my instructions section of the ribbon underneath basic instructions. I go down to counters, and again, you'll see here I've got all 6 counters. Again, the first 3 here are the 16-bit, the word-based counters. The bottom 3 are the 32-bit, or the double word counters. It really doesn't matter which one of these that I choose. In other words, if I just pick one and left-click to drop it in, I can adjust it from within the dialog box when I double-click on the counter. In other words, I can make it an adding, dual pulse, or up-down selectable, and I can also change the data type from within the dialog. Okay? So while the type of counter certainly is important, Which one of these you choose to start working with doesn't really make a difference, again, because we can modify that selection once we double click on our counter. Okay? So again, in this example, I'm doing just a word-based counter, adding counter. So I'll change that to an adding counter of data type with a word, 16 bits. Here I need to give it a counter number, and I can either type in, for example, C for the counter number and then whatever number I want to use, or I can simply just type in the counter number. Either way is fine, the software will take it both. Okay. For my preset, here again, I can choose either a data register or a constant. For this example, I'll just do a constant. I'll say it's a value of 5. Click OK. And again, I've got my pulse input. Again, what's going to make my counter increment. And for this, I'm going to use input I1. I1. And that's going to be my pulse. And I'm going to get rid of that ladder line there. All right. So that's my adding counter. Again, when I get pulses on input 1, the counter will increment up to its preset value. When it hits the preset, the counter will turn on or true. And whenever I turn on input 0, that will reset the value of the counter back to 0. Let me go ahead and download this. And I'm connected to just a little FC6A D16 here in my office. Go ahead and download that. And let me go into monitor mode. And let me open up this custom monitor dialog box I created so we can see this a little easier. Again, input 0 is my reset. Input 1 is my pulse. CC0, remember CC is the current value of the counter. So as I increment the value of the counter, I can see it count up here. It also shows my counter preset is 5. And C0 here I'm looking at as a bit. And again, what's going to happen is when the counter reaches its preset value, the counter will turn true. That bit, C0 here, will be on. So let's take a look at that. Let me start pressing the push button I've got wired into input 1, and we'll increment the counter. And again, it doesn't matter how long input 1 stays on. We're just looking for that rising edge transition. Okay. Now, once I get to 5, what's going to happen, again, C0 here, this bit will turn on. My counter will turn bright red as well. Okay. Because I've hit my preset value. So my counter turns true. So any additional logic that we would have put outside here on the right side of the counter would have executed. Okay. So I could have had an output out here to control if I wanted to, or any additional logic that I wanted. Once the counter hit its preset of 5, that additional logic out here would have been executed. Okay. Now, let's say I continue to get pulses here, right? You'll notice that that's not incrementing any further. It cannot count past its preset value. Okay. When I turn on input 0, it will reset the value of the counter. So my current value will go back to 0, and my counter bit here will turn off. Okay. And like I mentioned, if your reset input is on and you get pulses on input 1, right, it's not counting, right? Because the reset is almost like a master. Again, as long as it's on, you're not going to get any counts, even if you get pulses coming in on your pulse input. All right, that's an adding counter, or a lot of people call them up counters because they count up. All right, let me go back out of monitor mode. Let me scroll this down a little bit. You guys can see this, not quite that far. Go up just a little. We're going to call that good. All right, so the next one we're going to do an example of is a dual pulse reversible. Again, this one's got 3 inputs to it. The counter has 3 inputs. The top input is the preset. And whenever that turns on, the preset value gets moved into the current value of the counter. And for this example, we'll use just an internal relay M0 in the PLC. For the up pulse, again, whenever that turns on, the counter will increment by 1. We'll use internal relay M1. And for the down pulse, again, when that turns on, the counter will decrement. And we'll use internal relay M2 for that. Okay. Some notes about the dual pulse reversible. Again, the counter will be true, or the counter output will turn on whenever the current value of the counter is 0. Okay. If you have a conflict in your pulses, in other words, if my up pulse is on and then I get a down pulse that comes on, your current value will be decremented. If the opposite is true, if your down pulse is on and then you get an up pulse coming in, the current value will be incremented. Okay. If your preset input is on, again, that moves the preset value into the current value of the counter. If the preset input is on and you get pulses coming in on either the up pulse or the down pulse, they won't be counted. Okay. Just like the reset input on the adding counter forces the counter value to 0, the preset input forces the value of the counter to its preset value. Now, one thing that's different about this counter as to the adding counter is dual pulse reversible and the up-down selection reversible counter can count past their preset value. Okay, so in other words, let's say we're working with a word counter, 0 to 65,535, and we get an up pulse. The counter will overflow to a value of 0. It'll count past 65,535, its maximum. It'll roll back over to the beginning. Likewise, if you've got a word-based counter and you have a value of 0 and you get a down pulse, the counter will underflow. So it'll count from 0, it'll take 1 away, that'll be back at its maximum value, 65,535. Okay? That's also true of double word counters, the ones that count from 0 to 4.294 billion. Same premise holds true. They can overflow and underflow just as well. Okay? All right, let's do an example. Let me come down here in the logic and move that up just a little. And again, the first input that I put in is my preset input. And I'm going to use a normally open contact here of M0. That's my preset input. Let me go ahead and drop in my counter. Basic instructions, counter, and again, this is a dual pulse reversible. Double click to edit my counter. And I'll just use counter number 1 since that's the next one in line. And again, the preset can be a data register or a constant. Again, for this example, I'll just use a constant. We will do an example where we do a data register for a preset so you guys can see that. I click OK. Again, my up pulse is going to be internal relay M1. And my down pulse is going to be internal relay M2. Okay. Let me download this. And let's take a look at it. All right. So here, again, I created a custom monitor box for this dual pulse counter. Again, M0 is the preset value. So when that turns on, it moves a value of 3 into the counter preset. Okay. M1 is my up pulse. M2 is my down pulse. CC1 is just the current value of this counter. C1 as a bit, again, that is the output of the counter. Again, that's going to be on whenever this counter has a value of 0. Okay. Now again, I can get up pulses and I'll count up. I can get down pulses and I'll count down. Okay. And for example, once I get to 0 here, my counter turns true, it's 0. and the output, the bit for my counter, turns on. And again, now if I get another down pulse here, it will underflow and go back to 65,535. Okay? And again, that's because this is a word-based counter. Again, now if I start getting up pulses, okay, I'm at 65,535. The next up pulse that I get should cause the counter to overflow to a value of 0. My counter should turn on, and this counter C1 bit should also turn on. Okay, so I get an up pulse, I go to 0 on my count value. Again, my counter bit here is on. Okay. And if I turn on my preset, again, that moves the value of 3 back into the current value of the counter. All right, that's the dual pulse reversible. We get out of monitor mode, we'll go down and we'll do an example of the up-down selection reversible. Scroll that up just a little more. Okay. All right, so just like before, I'm going to use some internal relays to control the counter. Move that up just a little. So in this example, I'm going to use M100 for the preset input. Okay, and again, the preset input turns on, the preset value gets moved into the current value of your counter. I'm going to use M101 as the pulse input, and again, that's what's going to cause the counter to count. The third input is my direction, up or down. And again, if it's off, then the counter decrements. If it's on, the counter will increment. Okay. And just like the last counter that we did, the output of the counter will be on when its current value is 0. If your preset input is on and you get pulses coming in, they won't be counted. This counter can also count past its preset, just like we looked at. It can underflow or overflow. Okay. So let's put this thing in. So again, in this example, I was going to use internal relay M100 as my preset input. 100, and that's my preset. And if I put in a counter here, and again, I can put in whatever counter I want and then change it in the dialog. This is an up-down selection reversible. Again, I'm still going to be working with a word data type counter. If I needed to count up to 500,000, I would just change that to a double word, right? All you got to do is change the data type. This I'll use counter number 2, for example. And I'll give this a preset value of 3 as well. Again, my next input on my counter is my pulse. I'll use M101 for that. And my direction, my up-down direction bit, or my pulse here, I'll use internal relay M102. Go ahead and download that. Let me go into monitor and bring up the custom monitor box for this counter. Okay. So just like before, I've got the 3 bits that are working with the counter up top. M100 is the preset, 101 is my pulse input, 102 is my direction bit. Down here, CC2 is the current value of the counter, and C2 as a bit is the counter output. Okay. So again, if I turn on M100, that'll move the preset value into the current value of the counter. If my up-down selection bit here, M102, is off and I get pulses, I'm counting down. If my up-down selection bit is on and I get pulses, I count up. Okay. And again, once I reach a value of 0, the counter turns true. It's on. The current value is 0. The counter bit is on. And again, I can underflow and overflow as well. Okay? So if I get another down pulse, I underflow back up to 65,535. If I change my direction bit here and turn it on and I get a pulse, I'm going to increment. So it'll go from 65,535 to 0. Okay? And again, this counter is on or true only when the value is 0. All right? That's the up-down selection reversible counter. All right. So those are the three types of counters. Again, I could have used double word. I just used single word as the data type. We could have used double word. They would have been programmed the same way. Let's go down and we'll look at doing some comparisons. Okay, we talked about some of those comparison instructions. Let's put some in. The first one I'll do is the counter comparison, and those are in my Home tab underneath Basic Instructions and down to Counter Comparison. Again, there's only two. I can do an evaluation of the counter when it's equal to something or greater than or equal to something. Okay. Again, these can go right up against the left power rail. They don't need an input. And for this example, let's say I want to check the value of counter 0, current value of counter 0, and I can put in a 0 here or CC0 either way. It knows, since I'm doing a counter comparison, it knows to look at the current value of whatever I put in here. Okay. And let's say I want to see if it has a value greater than or equal to maybe 4. Again, this preset here can be a data register. It can be a hard-coded constant, just like this. Okay. And let's say if my counter is greater than or equal to 4, then I want to turn on an output. So let me go get a basic instruction, a real-world output, and let me make that Q2. So if my counter is greater than 4, I'm going to turn on Q2. That's a counter comparison instruction. Okay. Again, I could have additional logic out here. I could have additional counter comparison or data comparison instructions or whatever I need. I can sequence the logic however I need to. This is just a simple example. All right, let me scroll this up a little bit. Let's do an example of the load comparison instruction. Okay. Now I'm going to do the same comparison. I'm going to look at the current value of counter 0 and see if it's greater than or equal to 4, and then I'll turn on another output. I'll use internal relay M200, but it's doing the same comparison, the same function. So my load compares, those are actually in my advanced instructions tab underneath data comparison, all the way down here at the bottom of this box. And you can see this is what I call a full-blown compare instruction. In other words, I'm not limited to what I was with these counter compares, just equal to or greater than or equal to, right? With my load compare, I can compare equal, unequal, less than, greater than, less than or equal to, and greater than or equal to. So again, I'm going to make this match kind of what we did before. So I'm going to use a load compare greater than or equal to. Double click on that. Again, I've got the option here of selecting my data type, right? The counter comparison was based just on word data. So if I do a data type comparison here, I can choose a word, an integer, a double, a long, or a float. S1 is my source. What is it that I want to look at? Well, in this case, I want to look at the current value of counter 0. Okay. Source 2 is, what am I comparing that value to? And again, in this case, it's a number 4, constant 4. So this load compare instruction does exactly the same thing as that counter compare. It looks at the current value of counter 0. When it's greater than or equal to 4, it's going to do something. And again, in this example, I'm going to have it turn on an internal relay M200. All right, so we've looked at counter compare, we've looked at load compare. Let me go in and we'll do another full-blown comparison instruction, the CMP instruction. Scroll it up just a little. And if you guys remember from the presentation, the CMP instruction does need an input to tell it when to execute. So if I want to make it exactly the same as the counter comparison and my load compare, which execute on every scan of the program, then to make the compare instruction execute on every scan of the program, I would need a normally open contact of special internal relay M8125. Again, that's our in operation output. I call it the always on bit because it's always on whenever the PLC is in run mode. Now my compares, my CMP instructions are also in advanced and data comparison up here at the top. And again, I call these a full-blown compare instruction because I can compare equal to, unequal to, less than, greater than, less than or equal, or greater than or equal. Okay. Again, I'm going to make it the same as the other three, so this is going to be a greater than or equal. You double-click on this to edit it. And here again, I've got, for my data type, I can choose any of the 5 data types within the PLC. Since I'm still looking at counter 0 for this, it's still going to be a word data type. So I've got 2 sources. I'm going to compare source 1 is the current value of counter 0. Source 2 is what are we comparing it to? Again, that can be a constant or a data register. In this example, I'll make it a constant. And for my destination here, D1 is my first destination. It's what bit device do I want to turn on when this compare instruction is true? And again, this can be an internal relay. It can be a real world output, a Q. In this example, I'll use M201. All right. So those are the 3 comparison instructions, 3 different types that I want to take a look at. Now, let me go ahead and download that, and we'll see how each of those work. And let me go into monitor mode, go into custom, and open up the little dialog box that I made for this. Okay. All right. So in this example, again, I was looking at counter 0. Right? If you remember from our first example up here, from counter 0, input 0 was my reset, input 1 was my pulse. So I've got those listed up here in this custom monitor box. Here at CC0, I'm looking at the current value of counter 0 as a word. I'm looking at the output of the counter C0 as a bit to see when the counter turns on or not. And then down below that in the custom box here, I've got the 3 outputs, if you will, that I was controlling based on all 3 of those instructions. The counter comparison was directly controlling output Q2, so I'm looking at that as a bit. My load comparison instruction was controlling internal relay M200, again, as a bit. And the full-blown compare, the CMP instruction, is controlling internal relay M201, again, as a bit up here. So this way, as I control the counter, I can see the current value of my counter change. I can see the counter output turn on. I can also see if those 3 comparison instructions are working based on what these bits are doing here, Q2, M200, and M201. And again, those 3 instructions are the same, so whenever that counter hits 4 or greater, Q2, M200, and M201 should be on. Let's see if it works. So as I start incrementing my counter, you can see I've got a pulse here on input 1, my counter increments. Go to 2, go to 3. Now on the next input on input 1, all of these comparison instructions should be true because the current value of the counter will be greater than or equal to 4. So if I get a pulse on input 1, the counter increments to 4, all 3 of these comparison instructions are true. So Q2 is on, M200 is on, and M201 is on. Okay. Again, if I get another pulse, it goes to 5. Those comparison instructions are still true. The counter value is greater than or equal to 4. Again, if I get pulses on I1, nothing's going to happen. I can't count past my preset in the adding counter. And if I turn on input 0, that will reset my current value of my counter back to 0. And all of these comparison instructions, the outputs of them should turn off because they aren't true anymore. The counter value is not greater than 4 at this point. Okay. So those are some of the different comparison instructions. All right. Now let's take a look at an example of using a data register as the preset value for that counter. You know, so far everything that I've done has just been hard-coded using a constant. Again, that's fine. If that's what you need in your application, use it. If you have an application though where you might need to change the preset value, you want to make it variable by, you know, maybe an operator using a touchscreen, give them the ability to tweak the counter preset value. You can do that, and I like using a data register to do that. So let's do an example of that. The first thing that I'll do is I'll use special internal relay M8120, our initialized pulse, or I call it the first scan bit, because again, that bit turns on for the first scan of the PLC and then it turns off. So I'm going to use that special internal relay M8120 to do a move. I'm going to move a value of 5 into data register D500, and I'm going to use data register D500 as the preset of the next counter that I create. Okay. Now, let's say I do have this on a touch screen, and maybe I don't want to allow the operator to touch a numerical input and type in a value. Maybe I've just got a couple of up and down buttons for them to increment or decrement this preset value. So let me build a logic for that. Maybe I've got a button on the touch screen that is tied to internal relay M300, and when they press that button and put in a one-shot, maybe that will increment my counter preset. So it'll increment the value in D500. So I can use an increment instruction to do that. Likewise, if I want to say I've got a down button on my touch screen, maybe that's tied to internal relay M301, and when the operator presses that, maybe it decrements my counter. Okay, or excuse me, it decrements my preset value of the counter. It doesn't decrement the counter. And those instructions are in where are they? I've got to find them. There they are. Binary arithmetic. So in advanced binary arithmetic, that's where I'm getting those increment and decrement instructions. Okay. So if I want to decrement, again, whatever value is in D500, and that's what I'm using as the counter preset. Okay. So again, just a little bit of logic here. PLC powers up, moves a value of 5 into D500. When the operator presses the up arrow button on the touchscreen and increments that counter preset value, he presses the down arrow button, it decrements the preset value. All right. Let me go ahead and I'll put in just another simple adding counter. So I'll use, let's say I'll use internal relay M305 as the reset for the counter. Again, this will be counter 3. My preset for that counter is data register D500. Okay. And for my pulse bit, let me just use internal relay M306, for example. Okay. Now, again, I haven't shown this, but you can hang outputs off your counters. For example, if I want to turn on, I don't know, let's say M1002, for example, whenever the counter turns true. I can do that right there in the logic. Okay. I can also use a normally open contact of the counter, right? I've been looking at it in those custom monitor dialog boxes. But I can use a normally open contact of the counter to control an output as well. little different output there, maybe M1001. Okay, so this run that I just put in here does the same thing as that. Well, it's a different address, obviously, but it does the same thing. So when the counter turns on, I put my output right here. It'll turn on M1002. If I didn't want to do it that way, I could have done it like I did here in run 9 with a normally open contact of the counter going to my output. Okay. Let's take a look at this. Monitor mode, and bring up a custom box that I made for this. Push that up at the top. Okay. And let me add, I didn't add M1002 in there. Let me put M1002 in here as a bit. All right, so in this custom monitor box, again, I've got M300 and M301. What that does, scroll my logic just a little so you guys can see that. Again, M300 and M301 simply increments and decrements the value in D500. Okay. Down here on my counter, I've got M305 as my reset input. I've got M306 as my pulse. C3 here, counter 3 is a bit, that's my counter output. Again, whenever the counter reaches its preset, that will turn on. I've got M1000, which I didn't use M1000 at all. So M1000 doesn't even need to be in here. I don't have that in my code. M1001 is down here. Whenever the counter turns true, that will turn on. And likewise up here, right off the edge of the counter, whenever the counter turns true, M1002 will turn on. Okay. So let me increment my counter here. And again, once I get to the preset value, which is 5, the counter turns true. Again, so I can have an output hanging off the counter that turns on. I can use a normally open contact of the counter to control an output, because you can see all 3 of those are on right here. I reset my counter. For example, if I want to now change the preset value from 5 to something else, again, this could be an operator doing this from a touchscreen. You could be pressing the up button to change the value from 5 to 6 to 7 to 8, for example. Or if you want to decrement the preset value, you can do the same thing. Press the down button on the touchscreen. Right. So now I just changed that preset value to 2. So whenever my counter hits a value of 2 now, the output turns on. Okay. So again, just a way that you can control outputs either directly on a counter or by using just the contact of the counter, and just a way that you can use up and down buttons to increment or decrement values on a touchscreen. Now, one other thing I want to show you guys before I go to the questions is everything I've been doing is just with one reset input or one preset and one pulse bit. What if you had multiple conditions, right? What if just wasn't M306 that controlled this counter? One thing that you can do is you can use your insert or append functionality. Okay, and again, that's in the Home tab in the editing section of your ribbon. You've got insert and append right here. I can insert a ladder line, a column, or a rung. Okay, so if I need to, maybe I've got 2 things that control the reset that have to be on at the same time before my counter gets reset. You know, I can cut the counter, move it over 1, paste it, then put my input in. That's fine. I cut the counter, put it over here, paste it, then I can put in whatever I want there. I can do that, no problem. The other way to do it is simply to insert a column or hit Shift and Insert on your keyboard. Okay, that will insert a column, right? Just like it did. Now, I don't want it here. I want it between, maybe I want it between here and here. Okay, So insert does whatever you're doing before where you have your cursor. So if I click on my counter block and do insert a column, it's just going to slide my counter over one, right? Just like if I insert a rung, it's going to put a rung before, it'll put a rung up here. So insert does things before where your cursor position is. Likewise, append if I want to insert some space in between these two contacts, right? In the example that we just did, if I insert a column here, you know, I could have another contact in parallel with that reset input. For example, in 307. I'm just making that address at random. So in that case, these two things would have to be on at the same time in order for the counter to get reset. Likewise, what if I have multiple options that can control my counter incrementing, right? I can append a ladder line, then I can come down here and put other contacts. And again, I'm just making up these addresses. I could put those in parallel with internal relay M306. So in this case, either M306 turning on or M310 and input I4 turning on will increment the counter. Okay. So again, just a way that you can do multiple conditions on your counter just by using insert and append just to slide things around, or again, to make your counter block bigger. Using a pen there. Right. See how that stretches your counter block out? So if I need to put multiple conditions in there for my reset as well, maybe something like that. And again, I'm just making this logic up, but just so you guys can see, you know, I can stretch this counter, if I will, to put whatever kind of logic I need for the reset and my pulse. The same holds true for the other two types of counters as well. All right. Let me take a look and see if we've got any questions. And we've got a few here. Let's see. For some reason, the HMI alarm settings webinar is not showing up. Yeah, all of the data is probably just not been gathered for that particular webinar. Again, as the data is compiled and the videos are processed by our Marcom department, then they will show up there. Let's see, which FC6A digital input card is suitable for 100 pulses per unit at 12 units per minute? Does the points coming with the FC6A as standard will work? I think the TTL will work for 0 to 24. Okay, so let me do the second question first. All of the inputs on the PLCs are 24-volt DC inputs. So when there's 0 voltage going to them, they're off. When there's 24 volts going to them, they're on. And again, these are the digital inputs. They will work down to about, I think it's about 17, 18 volts. That's kind of the threshold of when they will turn on. So in other words, you don't have to give them exactly 24 volts. If it's 23, 22, 21 volts, it's going to turn on. As far as sending it a frequency, you know, we did high-speed inputs during one of the webinars, high-speed counters. And those are to, if you're getting inputs that are either turning on and turning off faster than the scan time of the PLC, you would want to use a high-speed input and a high-speed counter, not a regular counter. These counters are suitable. It's going to depend on your scan time and how quickly and how often your inputs are turning on and off. For example, in this little program, if I monitor this and I click on my status button, you can see this thing is running at a scan time of a millisecond. Okay, so what that means is this entire program is getting executed 1,000 times a second. Okay, so for example, at 1,000 times a second, that would mean that this, let's say I'm looking at, I don't have a physical input there. Let me look at input 4. if I'm looking for input 4 to turn on and turn off, it can't happen more than 500 times a second. If it does, this counter is never going to see that. Likewise, in the real world, if that's a physical input, you've got a little bit of time for the input to go away and for the input to come on, just with the actual voltage signal that you are sending it. So, doing something 500 times a second, probably not something you want to use a regular counter for. If you're doing something that quickly, you'd want to be looking at a high-speed counter. Just my general rule of thumb, I don't like to use a regular counter for anything. Typically, because most scan times, once you get into a real program, you're going to be looking at, 8, 9, 10 milliseconds, which means, it's executing, say, 100 times a second, which means you'd be looking at something turning on and off 50 times a second to be able to catch it, because you got to see it turn on in one scan, see it turn off in the next. My general rule of thumb is if I've got something that's turning on and off more than 20, 25 times a second, I'll typically go ahead and use a high-speed counter to do that. Again, that's just me. You can do the math and figure out what will work for your applications. That's just my rule of thumb. What's the max pulses per unit do these cards allow? Again, that's you're looking at on the digital input side, it's 0 to 24 volt. The frequency is going to depend on your application, but what I just mentioned is kind of the rule of thumb I typically go by. Let's see, what other questions do we have? For example, let's say I have 100 pulses per gallon. I count for an hour. I want to immediately start the counter without losing any input counts. If you're to do that and make sure you don't lose any input counts, depends on how many gallons you're planning on getting per hour. If it's 1 gallon an hour, then the standard counter will handle that. If you're doing 5,000 gallons an hour, then you'd want to definitely go with a high-speed counter and use the high-speed counter controls to do that. As far as downloading, does it matter when you download with ASCII and download with binary? No. Again, when we download these options up here for transfer mode for binary and ASCII, what that comes from is back in the days when we used to use dial-up modems for remote control and remote access of these things. Based on the modem that you were using, it had to have a certain transfer mode. For just downloading anymore, it doesn't make any difference. Let's see, can I pulse the input M306 from the ladder logic, or do I need an HMI? No, I can do it from the ladder logic like I did. I could have a touchscreen that has a momentary button that is addressed M306 to pulse it as well. I can do it either way. Let's see, why does the program not responding message show up when downloading or starting the software? I didn't see it today, but I've seen it before. Basically what happens is the software needs a certain amount of memory to run and execute. They may have had a lot of stuff open on their laptop that was using the memory on their laptop. That's what that'll mean. All right, guys. Well, that's all the questions from right now. We appreciate you guys taking the time to join this, and we hope to see you guys on another webinar. Hope you all stay safe. We'll talk to you later.